Alright, we're going to look at how to graph logarithmic functions, but before that we need to know how to make sure we know how to graph the exponential function with the same base. So if my equation is f of x equals to 10 to the power of x, remember the logarithmic equivalent of this is, instead of f of x, we're going to use g of x, and the base is 10, so that's when you write log, it's just base 10. So it's just log x. So these two are inverses of each other, and we'll see how we're going to graph this. So let's go and graph this first. So first thing, whenever you're given an exponential function to graph, keep in mind exponential graphs have a horizontal asymptote. Horizontal asymptote basically means it's a horizontal line. That means it goes through some y value. So the default is y equals to 0. So this is my horizontal asymptote of an exponential graph. So exponential graphs always have horizontal asymptote. And then this is the table that I use, 10 to the power of x. When x equals -1, it's 1/10. X equals to 0, y, it's 10 to the power of 0 is 1, 10 to the power of 1 is 10. Let's go ahead and graph this. When x equals -1, y equals to 1/10. When x equals to 0, y equals to 1. And then when x equals to 1, y equals to 10. It's somewhere here. And then remember, you join these 3 points, it's growing so quickly because the base is 10, and on the other side it hugs the asymptote. You don't really touch it, but you get really close to it and you hug it. So this is my f of x, which is an exponential graph. Now let's go and fill these up. The domain, let's go ahead and fill the domain in. So domain is basically all real numbers, or you can write it as -infinity up to positive, or all real numbers. Range is where, the graph is above 0 and 0 doesn't get included. So it's 0 to infinity. Asymptote, so it has a horizontal asymptote of y equals to 0. And then when they're talking about reference point, it's basically that 1 point, 0, 1. And then let's look at the end behavior. As x is going towards -infinity, what is happening to y? Y is not going beyond 0, so 0. As x is going towards positive infinity, what's happening to my y? Y is going towards infinity. Y is going towards infinity. Alright, now that I have my exponential graph in place, let's look at how the inverse graph looks like. So g of x equals to log of x. So remember, when you have inverse functions, this is the inverse of this, you switch the x and y. So basically what we'll do is my x is all these values, 1/10, 1 and 10, and my y is going to be -1, 0 and 1, which is log of x. And you're going to graph this one. Okay, another thing you need to remember, that because you switch the x and y, instead of having a horizontal asymptote, it will have a vertical asymptote of x equals to 0. So how does the line x equals to 0 look like? So my x values are here, and it's a vertical asymptote, so it will look like this. So this is my vertical asymptote for a logarithmic function. And let's go ahead and graph how the graph looks like. So when x equals to 1/10, y equals to, when x equals to 1/10, y equals to -1. So it's a point somewhere here. Then when x equals to 1, y equals to 0. And then when x equals to 10, y equals to 1. So that's somewhere here. So I join these 3 points, and it hugs the asymptote. It hugs the vertical asymptote. So you join these 2, and then you hug it. So this is my g of x, which is a log. So the log looks like this with a vertical asymptote, and then my exponential looks like this with a horizontal asymptote. And remember, inverse functions are reflected on y equal to x. So if I draw this y equal to x, you'll see that the 2 graphs are reflected. And let's go ahead and quickly fill this in. My domain starts at 0, ends at infinity. So you can actually switch the domain and range. This is -infinity. vertical asymptote. Logs have vertical asymptote of x equals to 0. And my reference point can also be switched as 1 equals to 0. Okay, now let's look at the limit, because the limit is a little different. My limit is going to be as x is going towards, so we are looking at this graph. We are looking just at this graph. Let me cover this graph. Should I cover this? I don't need this. So I'm only looking at this graph. I'm only looking at this graph. So this graph, I cannot say as x is going towards negative infinity, because there's no, x is actually stopping at 0. X is actually stopping at 0. That's why as x is going towards 0 from the positive side. So remember, from the positive, we have done limits. So positive side means coming from here. What's happening to my y? My y is going towards negative infinity. And then, but x is going towards positive infinity, y is going towards positive infinity. So the limits, you have to pay a little bit of information. So this is the new thing. So for logarithmic, on one side, it will not go towards positive infinity and negative. On the one side, there will be an asymptote that stops it, because it has a vertical asymptote, So I need you guys to pay attention to that. Alright, we will stop this and come back to this, pick up the next page on the next video.